Hey everyone, welcome back. So today we are continuing on with Unit 4B-2, and we're going to look at what happens when something is not factorable. How do you solve a quadratic that's not factorable? So that's where we're going to use what we call the quadratic formula. So the quadratic formula can be used to solve all quadratics. Not all quadratics are factorable. That is, no two numbers multiply to the last term and add to the middle term. In this case, you must use the quadratic formula. So for example, if I had x squared plus 7x plus 13 equals 0, this is what would look like to be a SAM problem, but the only thing that multiplies to 13 is 1 times 13. And when I add 1 and 13 together, I get 14. If I subtract them, I get 12, which isn't 7. So in this case, you can't factor this, so to solve it, you'd have to use the quadratic formula. Now this is the quadratic formula. I will show you a video in class, but I'll sing it for you. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I know, I should be an American Idol singer one day. Who knows, maybe The Voice. I gotta choose which one I want. Anyway, this is a quadratic formula. It is good to know, however, we will provide it for you on all your tests and quizzes. So, notice how it says plus or minus here. That means you are going to get two solutions. Just like when we factored, we got two solutions. This plus or minus is what's going to give us two solutions. So here is our equation. We're going to solve 4x squared plus 4x equals 7. And it does say use the quadratic formula. I do like to factor if possible. But again, quadratic formula is a backup plan. And if it says use the quadratic formula, use the quadratic formula. So for number 1, you still have to get it equal to 0. Just like for factoring. So I'm going to subtract 7 to make the 7 a 0. And then there's no like terms. So I have it as 3 terms, 4x squared plus 4x minus 7 equals 0. And then once we do that, we see our quadratic formula. And our quadratic formula again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now notice, the a is what is in front of the x squared, the b is what's in front of the x, and the c is the number by itself. So if we're looking at this equation, your a is the number in front of the x squared, which is 4. Your b is the number in front of the x, which is 4 again, but this 4 now. And then the c is the number by itself, which would be negative 7. So we are substituting 4 for a, 4 for b, negative 7 for c. Now what I like to do is substitute those numbers in. X equals negative 4 plus or minus the square root of 4 squared minus 4 times this 4 times c, which is negative 7, all over 2 times 4. And what I like to do is I like to take this, we have to simplify this, so we have to figure out what this number is first. So what I like to do is just write this off to the side. Do this work off to the side. Do it over here. So 4 squared minus 4 times negative 7. So following PEMDAS, PEMDAS is really important for quadratic formula. There's nothing inside parentheses I can do, so I do exponents first. 4 squared, 16. And then I multiply. So I'm multiplying. 4 times 4 is 16, and 16 times negative 7 is negative 112. So I'd have minus 112. So it's minus a negative 112, which would really be 16 plus 112. So what I often do is I often look at the signs first. I have a negative and a positive, so that would make a positive. Two negatives make a positive, and then I usually just multiply my numbers. 4 times 4 times 7, which gives me 112. That way you don't have to worry about the signs. And then I have 112 plus 16 is 128. So I know that this number under the radical is now 128. So I'm going to rewrite that as x equals negative 4 plus or minus the square root of 128 all over 8 now. And remember, when a fraction is written top-bottom like this, there's really an imaginary set of parentheses around the top. So that's going to help us follow PEMDAS. So inside the parentheses, we have to take care of the top first because there's really imaginary parentheses there. And within that, we have to take care of exponents. And remember, a square root is an exponent. It's a fractional exponent, but it's an exponent. So I'm going to take the square root of 128. This happens to be 11.31. We can do 2 decimal places. If this happened to be a whole number, meaning this number is a perfect square, then that means it would have been factorable. This was not factorable, so quadratic formula really was our only option. All right, we're almost there. I know it's a long process. And now we're going to do the adding or subtracting along the top. So this is where I'm actually going to split into 2 separate problems now. I'm going to do negative 4 plus 11.31. all divided by 8, and then I'm going to do x equals negative 4 minus, again we're getting 2 answers here, 11.31 all divided by 8. And remember that imaginary set of parentheses around the top. So now you have 2 options. You can type this in your calculator all at one time using the parentheses, or you can type this in, negative 4 plus 11.31, press enter, and then divide by 8 if you'd like. But from here, that's kind of where I'm going to go. I like to use the parentheses, negative 4 plus 11.31 divided by 8. And again, I made sure that top was in parentheses. So I got 0.91375. And then I do the negative 4 minus. And there's my work, you can see. And then my other answer is x equals negative 1.91375. So the key here, I know it's a long process, that's why factoring is going to be faster if it's possible, but again, factoring wasn't possible here. Get that, once you have it written out, figure out what that number is underneath the radical using PEMDAS, following order of operations. Get that number underneath the radical, and then write it as 2 separate. And remember, don't forget there's a really imaginary set of parentheses around the top. All right, we'll do 2 other examples. So here's some more classwork. This is already set equal to 0. That's step 1. So we have a equals 1, b equals negative 1, c equals negative 6. And I'm just going to write our quadratic formula right in the middle here so I don't have to write it every single time. All right, so I write x equals negative b. So b is negative 1. Negative b would be negative 1, which is positive 1. Plus or minus the square root of negative 1 squared minus 4 times a, which is 1, times c, which is negative 6, all over 2 times 1. Again, what I like to do next is off to the side, look that underneath the radical and figure what that's going to be first. So following PEMDAS, I do my exponents. Negative 1 squared is 1. And then here's the trick I was saying. I have a negative times a positive, which is negative, times a negative, which would be positive, because 2 negatives make a positive. And now I don't worry about the signs. 4 times 1 is 4, and 4 times 6 is 24. And then 1 plus 24 is 25. So the number underneath the radical is now 25, which is a perfect square, which means this would have been factorable. 2 times 1 is 2. But since it does say use the quadratic formula, we're going to use that here. X equals 1 plus or minus, square root of 25 is 5, all over 2. Again, don't forget you have an imaginary set of parentheses around the top. So this is where we would write our 2 separate equations. X equals 1 plus 5, all divided by 2. And x equals 1 minus 5, all divided by 2. So 1 plus 5 is 6. 6 divided by 2 is 3. So one answer would be x equals 3. 1 minus 5 is negative 4. Negative 4 divided by 2 is negative 2. Second answer. Two answers, 3, negative 2. Let's try one more together. All right, this is already set equal to 0, so we are good shape for that. A equals 1, B equals 8, C equals 6. All right, I plug in what I know. X equals negative b, so negative 8 plus or minus the square root of b squared. So it'll be 8 squared minus 4 times 1 times 6 all over 2a. So 2 times 1. All right, I'm going to take then the thing underneath the radical. So 8 squared is 64. And then I have a negative times a positive, which would be negative, times a positive is still negative. So it'll be minus 4 times 1 is 4, times 6 is 24. 64 minus 24 is 40. So I would get 40 underneath that radical. And now when I rewrite it, it has the square root of 40 underneath. 2 times 1 is 2. Remember, I'm going to take the square root of 40 next. So 40 is not a perfect square, so this was not factorable. And the square root of 40 is 6.32. And remember, there's an imaginary set of parentheses around the top. So what we're going to do is write as two separate fractions, now two separate answers now because of that plus minus. So negative 8 plus 6.32 all divided by 2. Again, I like to put those parentheses around the top. X equals negative 8 minus 6.32 parentheses around the top all divided by 2. So if you type it in exactly how I have it written, you can type it in your calculator now. So in parentheses, negative 8 plus 6.32 divided by 2. So 0.84, negative 0.84 is one answer. And then I would have the same problem, but just a minus 6.32 now. And that would give me negative 7.16. I want you to do this fully on your own. First step, though, is to get the x or the equation equal to 0. So we have to subtract 7. And not only do we have to subtract 7, I want to rewrite it so it goes x squared x, then the number, so standard form. So I have a negative x squared, positive 13x, a negative 7 equals 0. So again, you always want to have it go x squared x, then your number. All right, go ahead and tell me what your a, b, and c are and start solving. All right, so a is equal to negative 1. B is what's in front of the x, which is 13. C is by itself, which is negative 7. So as I go and plug this in to my quadratic formula, again, I'll write it over here since you can't see it anymore. X equals negative b, so that'd be negative 13 plus or minus the square root of 13 squared minus 4 times negative 1 times negative 7 all over 2 times negative 1. All right, I like to look underneath that radical now. So underneath the radical, I have 13 squared, which is 169. And then look at my signs. Negative times a negative is positive, times a negative would be negative. So it'd be minus, and now I just worry about my numbers. 4 times 1 is 4, times 7 is 28. So 169 minus 28 is 141. It's not a perfect square, so that means it was not factorable. And we go ahead, negative 13 plus or minus the square root of 141 all over negative 2. Remember those parentheses really around the top. We take the square root of 141, which is 11.87. So I get negative 13 plus or minus 11.87 all divided by negative 2. So we go ahead and write two separate equations now. Negative 13 plus 11.87 all divided by negative 2. And then negative 13 minus 11.87 all divided by negative 2. And now we're ready to type them in. Again, make sure you're using the parentheses when you type it in. Negative 13 plus 11.87 divided by negative 2. And we get 0.565. Same thing, but now we have a plus or minus 11.87 instead, which is 12.435. All right, so that's our quadratic formula. Hopefully that song gets stuck in your head.